Okay, we're going to jump into lesson 11.1, which is on graphing systems of equations. So first we're going to just define what a system of equation means here. And so a system of equations is going to be two or more equations that have the same variable. And there's a couple different ways that we can go about solving this. So keep in mind we've got two variables, so two unknowns, and we've got two equations. And so if we want to solve for those variables, it's a little bit different because there's two of them, right? So we're going to use the equations with each other in order to find the solutions to both variables. And there's a couple different ways to do that, and one of them is going to be by graphing the equations. And so we have a couple options here when we go to graph them. These are going to be linear equations which produce lines, right? So if I'm going to graph two lines, I have a few options. And the first is that those lines intersect at one point. So I'll go ahead and draw just an example of what that might look like. So if I were to draw two lines on a graph, they could intersect at some point, and that point that they intersect would be my solution point. Right, so in this case it would be right there, which it looks like it's at -1, 1, and that would be my solution. So wherever they intersect is the solution, and we can see here it says this is when we have one solution. These are intersecting lines, and we know that these have different slopes because the steepness is different, right? One's positive, one's negative, okay, and so we can tell that these are going to intersect right off the bat because they have different slopes. Another option, though, that if I were to graph two lines, another option would be that they never run into each other, that they're parallel lines. So they would look something like this. And so this system would have no solutions because they never run into each other, and so there's no solution point, right? Because the point of intersection is the solution, and if they never run into each other, then we have no solutions, okay? And so these two lines have the same slope. We know they have the same slope because they're the same steepness here, right? The rise over run is the same for each of them, but they have different y-intercepts, so they crossed the x or the y-axis at different points, right? And we can see that they cross the y-axis at different points. So anytime we have same slope and different y-intercepts, we're going to have this no solution system of equations. And then the last option is that I graph these two lines and they end up just laying right on top of each other. So they're really just pretty much like the same line, right? So there's two lines here, but they're just laying on top of each other. So that means they're kind of always intersecting, which means that we have infinitely many solutions because they're always intersecting, and everywhere that they intersect is a solution. So if they're always intersecting, then that means we have infinitely many solutions. And these two lines, they're going to have the same slope and the same y-intercept, and so then we'll know that they're going to have infinitely many solutions. So let's go ahead and graph a couple of these. It says solve the system of equations by graphing. So we want to figure out x and y. That works for both of these equations here. And so we can do that by graphing and figuring out where the point of intersection is. Notice these are already set up pretty well for me because they're in slope-intercept form. So I'm just going to jump straight into solving or graphing these. We've got our b value at -4. And we've got our slope, our m value at 3. So that's going to be up 3 and to the right 1. Okay, and so I get this line that looks like this for the top equation. Looks something like a line. And then we've got this bottom equation here where my y-intercept is at 3. So I'll start there. And then this one has a slope of -1 over 2. So that's down 1 because it's negative and always running to the right 2. And so we can see these have a nice point of intersection here. And remember, that's going to be my solution. And so this has one solution because they intersect. So one solution, and I need to name that solution as an xy ordered pair here. It's at 2, 2. So x, y, in this case 2, 2. And so that would be my solution for this system of equations. We'll keep going here to the next one. This one's a little bit tricky. I'm going to start by graphing this bottom equation first. So I'm going to graph the bottom equation first. This is going to have a y-intercept at positive 4. So I'll start there. I'll begin there with my b value as my y-intercept, and then a slope of negative 5, and then to the right 2. So I'm going to go down 5, 2, 3, 4, and 5, and to the right 2. And I get those 2 points there, so I can go ahead and draw my line now. And then the other equation here is kind of tricky because notice there is no x term in this other equation, right? So what's happened here is the slope, the m value, which usually goes right in front of x, has disappeared, which means that it must have been 0. So in this case, on this top equation, the m value must be 0 because there is no x term, which means it just basically canceled out that x term from the top equation. Okay, so the m value is 0, and this is still my b value, this number here, just like normal. That's still my b value. So I have a y-intercept at negative 1, and then I have a slope of 0. And if you remember, slopes of 0 means that we have a horizontal line, so just a flat line going straight across here. And we can find our point of intersection is right here, and that's going to be our solution. And so we have one solution. We've got one solution, and it's going to be at 2, negative 1. And so anytime that we have a y equals and it's just a number, we're going to end up with this horizontal line, right? Because there is no slope. That means there's no slope there. So it's disappeared. It's 0. And so that means we just have that flat line. Okay, moving to letter C. Same idea here. I want you to notice first, though, for this top equation on letter C, it's not in slope-intercept form. So we could graph it using the intercepts, right? The x and the y-intercept that we've looked at before, or we can rearrange it and get y by itself. I think that's what I'm going to do here. So that would require me to subtract 2x from both sides. And so then I would get this new equation. I'll move it off to the right here that looks like this. Y equals negative 2x, because I would have to subtract it from both sides, and then plus that 2. And so then I would have these two equations here, right? The one I just rearranged and the original one that they gave me there. And I'm going to graph both of these. So this green equation here has a y-intercept as positive 2 and a slope at negative 2. So that's down 2 and to the right 1 because it's negative 2 over 1. Okay, and we can go ahead and connect those points there. Okay. And then we'll go ahead and graph this bottom equation too. And we can see the bottom equation, it has a y-intercept at negative 2 and a slope that is negative 2 over 1, so down 2 and over 1, right? And so then we can go ahead and draw that line. And we can see what's happening here is that these two lines are not going to intersect. And so these are going to be parallel lines. I know it looks a little bit like they are, but that's just because of my drawing there. These are not going to intersect. And the way that we would know that is because they have the same slope. So notice the slope for both of them. I'm going to write it down here. Same slope is negative 2, right? They have the same slope, but they have different y-intercepts. They have different y-intercepts, which means that they are parallel, which means we have no solution. And you don't need to write that every single time, but I just want you to notice that we've got same slope, different y-intercepts, which means we have parallel lines, and then we're going to have no solution. So you do need to write that it has no solution every time. And then finally, let's go down to this last one here, letter D. The top equation looks okay, right, in standard, well, I guess just to say in slope-intercept form. So then if I go ahead and graph that, we've got a y-intercept of negative 1 and a slope that's up 1 and to the right 3. Rise over run, up 1 and over 3. And so we'll go ahead and draw that line there. Okay, and then we have this other equation. It looks all sorts of funky down here. All right, I got to rearrange this to get y by itself. So I'm going to start by adding this 1/3 x to the other side. So that's going to give me y minus 2 equals positive 1/3 x. And then I got to finish this up by adding 2 to the other side. So I get y equals 1/3 x, and then adding 2 to the other side is a positive 2. Okay, and then I can go ahead and put this onto the graph. So positive 2, and then a slope of up 1 and over 3. And hopefully you're noticing again that we've got the same slope here. And if we've got the same slope, then we're going to have this parallel situation as long as we don't have the same y-intercept. And we can see that our y-intercepts are different. So again, this is going to be parallel, okay, and this is going to be no solution. Because remember, the solutions is wherever my graph intersects, and if they never intersect, then I'm not going to have any solutions. Okay, we're going to move down to the next one. It says determine if the system of equations has one solution, no solutions, or infinitely many solutions without graphing. So without doing any graphing, and we can do that all based on the slope and the y-intercept. So we need to know the slope and we need to know the y-intercept. So I'm going to write that here, slope and the y-intercept. And if we know that, then we can make this determination. So we know that the slope for the top equation is 2 and the y-intercept is 3. For the bottom equation, we can't tell because we have this negative 2x on the wrong side. So I'm going to go ahead and move that to the other side by adding it to get y by itself. And we'd get y equals positive 2x plus a 1. And so we have these parts. We have m is 2, b is 1 for that bottom equation, and up at the top we have m is 2 and b is 3. And so we have the same slope, but we have different y-intercepts, right? Because 3 and 1 are different. So same slope, different y-intercepts. If you scroll over here to the top left, we can check this out. It says if we have the same slope and different y-intercepts, we're going to end up with no solution here. So these are going to end up being parallel lines, and so we're going to have no solution, and we know that without even graphing. So that's the same slope and different y-intercepts gives me no solutions. All right, keep going here. Same idea. They want us to determine if we have no solution, one solution, or infinitely many solutions, and I need to know the same information. So I can see already for the top equation, I have m and I have b. The bottom equation I can't tell, so I'm going to go ahead and divide by 2 to get y by itself. And we get y equals, is going to be negative 3x, and then plus 2. And so you're going to notice here we've got slopes at negative 3 and negative 3, so same slope. Y-intercepts at 2 and 2, so that's same slope, same y-intercept. So if you go back to the first page there in the top left, it says same slope, same y-intercept. Well, that's just going to give me the same line, so 2 lines on top of each other there, and so that's going to be infinitely many solutions. Same slope and same y-intercept, so infinitely many solutions. All right, and we'll finish this one up here. It says Ren and Jenny are reading the same book. Ren is on page 12 and reads 4 pages every night. Jenny is on page 4 and reads 5 pages every night. Okay, after how many nights will they have read the same number of pages? So when have they read the same number of pages? So first I'm going to set up an equation for Ren, and it looks like this. Y equals, well, she's starting on page 12. That's her initial value, and the rate is 4 pages per night. So remember, the rate is the slope, so that's 4x, plus the initial value, which is 12. That's for Ren. And for Jenny, she's on page 4 and reading 5 pages every night, so that's going to be y equals 5x, that's the rate, and then plus 4, the initial value. And so we have these two equations, and we can graph these and put them on the graph and see where they intersect, and that's one way that we could do it. And we can also set them equal to each other, which we've seen before. Okay, so I'm going to start to graph them, and then I'm going to set them equal to each other in a second. So for Ren, that's the green equation here, starting at 12, and then up 4 and over 1. Okay, so it's going to look something like this, and I could continue to follow this pattern, up 4 over 1, up 4 over 1, up 4 over 1. Okay, but for the sake of time, I'm going to draw my line here. All right. And then for Jenny here, starting at 4, and then up 5 and over 1. And I can draw my line here. Okay, and so they're going to intersect somewhere in this area, right? This is just drawn by hand, so it's not perfect, but the way we can figure this out perfectly is by setting these two equal to each other. So I'm going to say 4x plus 12 equals 5x plus 4. And then I'm going to solve this. I'm going to subtract 4x. I get 12 equals x plus 4. Add 4 to the other side. And so I'm going to get x equals, subtract 4 to the other side. X equals 8. Okay, so that's the number of nights. So this is going to be 8 nights. And then if I want to figure out what page they're on, well, I can just take this 8 and I can plug it into either one of these equations for x, right? So it doesn't matter. I can plug it into either one. Okay, so if I decide to plug it into the green equation, it's going to look like this. Y equals, remember my equation was 4x plus 12, so that's going to be 4 times 8 plus 12. And so that's going to be y equals 32 plus 12, and I get y equals 44. And that's going to be the page that they're on. So that's 44 page. Okay, so on the 8th night, they'll be on the same page, which is going to be page 44. All right, thanks for watching.